Okay, so here, so always start with the linear equation. So the linear equation is the one without any square or any cube. Okay, it's just line. So it's only x and y. All right. So we start from here, and then you make either x or y the subject of the formula. Of course, if I were you, I'll go for this one. Okay. So always look for the variable without any coefficient. I mean without any number, only y, something like this, right? And then next is you need to make y the subject of the equation. So basically move everything to the other side except y. And then what's next? So once you're here, so once you have expressed this in terms of x, or make the subject y, you now go to the other equation that you did not choose. All right. And then we'll start from there. And then what's next after that? We are going to substitute the value of y that you have made from the first equation into the other equation. So if you have y squared here, that means that this y will now become 4 minus 2x. And then, of course, you have to take the square. Okay. And then bring down minus 4, 0, of course. Okay, so from there, so how do you expand this? When you expand this one, it's 4 minus 2x multiplied by, again, 4 minus 2x. When you do that, you'll get this one. 16 minus 16x plus 4x squared. Okay, so that's what you'll get after you have expanded this. And then bring down minus 4x and 0 again. All right, so what's next after that? Now, we are trying to solve this by quadratic equation, right? Because it's clearly a quadratic equation because we have the square here. So we need to rearrange this in the standard form. Ax squared plus bx plus c equals 0. So doing so, so bring down 4x squared, and then negative 16x minus 4x is negative 20x, and then 16, we just put 16 over there, and then equals 0. So you now have your quadratic equation. Now, class, try to observe the coefficients of each of the term. Okay. Now, if you have observed closely, all of these three numbers are all divisible by 4, right? Because class, when we solve quadratic equations or any equations, we want to make the numbers as small as possible. All right, so in this one, it's possible because all of these numbers are divisible by 4. So that's what I did. And now we only have x squared minus 5x plus 4 equals 0. All right, gets? So that's what happened. That's why it now looks more or much simpler. Okay, and it's easier to solve, of course, if you have smaller numbers. All right, so from here, it's up to you now which method you want to use. You can just factorize, or you can just use the quadratic formula. It's up to you, class. All right. Now, for me, what I did, I just factorized this one. Okay. So since this is much simpler to factorize than to use the quadratic formula. But later I'll have some examples on which I'll use the quadratic formula. All right, it just takes more time, but the hang of it, guys. All right, so basically, how did I factor this out? So factorize. So wait, let me just write it here. So what I did here, of course, is I factorized this one. Okay. So when you factorize this, since this is equal to 1. Okay. So what are the factors of 4 that when you add them, it's negative 5? Okay, so when you factor out negative 4 times negative 1, it's positive 4. And then when you add this 2, it's equal to negative 5, right? So that means that those are the factors of this equation right here. So you have x minus 4 and x minus 1 equals 0. So this is the factored form of this one. All right. So from here, of course, you need to solve for the two values of x because again, um, a nonlinear and a linear equation always intersects or mostly intersects at 2 points. Okay. So it becomes x minus 4 equals 0, and then x minus 1 equals 0 over here. So therefore, the values of your x are 4 and 1. Okay. And then, of course, if we have two values for x, we also have two values for y. And that's where this part comes in. Okay. So when x is equal to 4 and then x is equal to 1, right? So for this one, to solve for y, we need to go back to the um, equation that you did. All right. So the first one. Okay. So y is equal to 4 minus 2x. So basically, that's what you'll use to find for the two values of y. So this is 1 when x is 4. So x here becomes 4, right? So therefore, y here is negative 4. So your first point is 4, negative 4. And then your second point is when x is equal to 1. So you plug in 1 here. So 4 minus 2 is simply 2. So your second point is at 1 and 2, or 1 comma 2. So here are your answers, class. So 4, negative 4, and 1 and or 1 comma 2. Okay, so do you guys have any question on number 1? All right, now let's go to number 2. Okay, now for number 2, of course, it looks more complicated, right? Okay, so again, the first step is you need to go to the or choose the linear equation first. So which is the linear equation here? Of course, it's the first one, okay, because it doesn't have any indices, right? Okay, so once you have chosen that, so we have x plus y equals 2, and then either you make x or y the subject of the equation. So for me, I'll just make y the subject and then transpose x to the other side. Okay, so I'll have y equals 2 minus x. So that's it for the first equation for number 2. Now, the second step is to, of course, choose the other equation because we are going to substitute it into the other equation. So I'll write it again and then take note that y is equal to 2 minus x. So this y here becomes 2 minus x. Okay, so that's what happened there. And then the rest, you just bring down everything else. Okay, so you're now here. So we need to remove the brackets before we can simplify. So distribute, you'll get 2x minus x squared, and then bring down this, bring down all of this. Okay, and then what's next after this? So you need to combine this and make it in standard form. Okay, standard form. So this is already in standard form. So x squared plus 2x plus 1. And then from here, again, this is already in standard quadratic equation. It's up to you if you want to factorize or use the quadratic formula. Okay, if you use the quadratic formula, it's totally fine. All right, it might take a little longer, but it's okay. All right. All right. So for me, I just factorize this one. Okay, because it's much faster and simpler. All right. So what are the factors of 1 that when you add them, it's positive 2? So of course, obviously it is 1 times 1. And then when you add 1 plus 1, you'll get 2 as your answer. So that's by factorization. So these are the, or this is the factored form of this equation right here. All right. So meaning class, you have x plus 1 and another x plus 1 equals 0. All right. Now, is that possible that they're the same? Yes, of course. Okay. So basically, class, your answer will be just the same, negative 1 and negative 1. So that means, class, that these two equations here will just intersect at one point because both of your x's here are equal. All right. Now, let's check this on Desmos. Let's see this on Desmos. Okay. So these are the two. So here's the graph for both equations. So the red one is the linear one, obviously, and then the blue one is um, the curved um, graph. Okay, so look, they only intersected at how many points? At one point. If you zoom this, they will only intersect at this point, -1 and 3. Right? So -1 and 3. So that should be our answer. And we already got the x value, which is -1, right? So to find for the y value, you don't have to do it twice because, again, they're just the same, right? Okay, so when x is equal to -1, y is equal to, it came from here again, okay, 2 minus x. So therefore, y is equal to 3. So that means that the point or their intersection point is -1, 3. Okay, that means the two equations will only intersect at 1 point. So that's what happened here. Okay, so if you zoom this closely, yeah, it's just at 1 point. Yes, it's possible. All right. Okay. Okay. Now let's go to number 5. Number 5. You're given two equations, of course. You have x plus y equals 5, and then the other one is x plus 1 squared plus y plus 1 squared equals 25. Okay. Again, choose first the linear equation. So it's the x plus y equals 5. And then make either x or y the subject. So for me, I made y the subject of the formula. So it's now y equals 5 minus x. So that's it. Okay. So what's next after that? So after that, I'm going to write the other equation. And then I'm going to substitute this in place of y. So you see this y over here. So I'm going to replace this with 5 minus x. Okay, so that's it for that step. Now, question: what if there are two y's or maybe three y's in an equation? Should I also substitute that with 5 minus x? Yes, of course. For example, there's 25y here. So that means you also need to put 5 minus x over here. As long as there is a letter y or a variable y, you should substitute that with this one. Okay. So in this case, let's go back to our question. All right, let me zoom in because I think it's too small. All right, so from here, what do we do now? So we expand this. Okay, so x plus 1 times x plus 1, x plus 1. So you get x squared plus 2x plus 1. All right, so from here, it becomes this one. Okay, and then this one, you simplify this first. You'll get 6 minus x squared, right? So don't forget the square equals 25. So bring down 25. And then you just bring down this, bring down 25, and then you expand 6 minus x. So 6 minus x times 6 minus x. So what you'll get? You'll get 36 minus 12x plus x squared, okay, equals 25. So we are now here. So what is next after that? We combine like terms, okay? So let me just put it here. Combine like terms. Of course, you need to change this in standard form, right? So combine like terms. So x squared plus x squared is 2x squared, right? And then 2x minus 12x is minus 10x. And then 1 plus 36 minus 25. This is minus 25 because you transpose it here, right? So it's equal to 12. So this is what happens after you have combined all the like terms. Okay, and then observe. Is 2, 10, and 12, are they divisible by a number? Yes, of course. They are all divisible by 2, right? So we can make the numbers smaller. So that's how I got x squared minus 5x plus 6 equals 0. And then from here, so this is already in a standard form. Okay, it's either you factorize or you use the quadratic formula. So for everyone's sake, I also showed here, what if I use the quadratic formula? Will I still get the same answer like what I did for factorization? Okay, so let's find out. So first, I'll go first with factorization. So when I factorize this, I'll get x minus 3 times x minus 2. How did I get this? What are the factors of 6? That when you add them, it's negative 5. So when you multiply negative 3 and negative 2, you'll get positive 6, right? But when you add negative 3 and negative 2, you'll get negative 5. So these are the correct factors. So this is x, and then you have negative 3 and negative 2, or minus 3 minus 2 equals 0. So therefore, the values of x will be 3 and 2. Now, what if I forgot about factorization? I still remember quadratic formula. Can I still use that? Of course, you can still use quadratic formula. Okay, but be careful. This is A, this is B, and then this is C, right? So this is the quadratic formula, so negative B. So that's why it's um, negative 5. Okay. Sorry, this is negative 5. All right. Anyway, I'm still correct. So this should be positive 5, not negative 5. All right. Oops. Okay. Sorry. All right. So anyway, let's go. So this is the quadratic formula. So it's negative b. B here is negative 5. So it's negative of negative 5. And then plus minus the square root of. So b squared. So 5 squared minus 4ac. So 4, what is a? A is 1. C is 6. Then over 2 times a, which is 2 times 1. This is a. Okay, so this is your formula. Let's simplify this. So this is positive 5. And then this is 25 minus 24, right? This is 25 minus 24. So therefore, the square root of 1 is a positive and negative 1. So you separate the two. So you have 5 plus 1 divided by 2, which you'll get 3, right? And then the other one is 5 minus 1 divided by 2, which you'll get 2. So either way, class, it's up to you which one do you prefer, either factorization or quadratic formula. Okay, so yeah, those are the values of x. So what are now the values of y? So when x is equal to 3 and equal to 2, so we use the same formula from the first one to get the value of y. So y is equal to 5 minus x. So 5 minus 3 is 2. So your first point is at 3 comma 2. And then for your second point, when x is equal to 2, so 5 minus 2 is 3. So your second point is at 2 comma 3. So these are your answers. And we can go back here and check, right? So that's it. So we are correct. So it's the intersection of a line and a circle. Okay, do you guys have any questions about this one? Number 5. Okay, so I have here number 7, but I won't explain this because it'll take too much of our time. I'll just skip it right here. Okay, so you guys have a guide on some questions. All right, and then this is number 13. All right, this is number 13. This is my answer for number 13. My answers are in decimal. I use decimal for this set of points because um, it's easier for me to graph the points if it's in decimal than in fraction, right? Okay, so number 13. So number 13, it says here, we need to find the coordinates of the points of intersection of the line 2x plus 3y plus 2 equals 0 with the curve 2xy equals negative 1. So let me show you guys that simultaneous equation in Desmos.
Mister, can I go to the toilet?
Oh yes, you go ahead. All right, so that is 2x plus 3y plus 2. So 2x. So this is the line, the purple line, and then this is the okay, so those are your graph. Okay, so basically class, as you guys can see, it will intersect in 2 points. So at here on the upper one, it's negative 1.5 and 0.333, and then on the bottom part, it's zero point 0.5 and negative 1. So how can we come up with those two answers? How can we solve for those 2 points? Okay, so it's just the same process, class. So we start with the linear one. Um, okay, so what I did here, um, okay, sorry. So I went with um, the other equation. Okay, all right. So what I did is I made y the subject of this one. Okay, I made y the subject of this one. So basically, I need to remove 2x and put it on the other side, but you cannot transpose this. It's not like plus 2x. It's not like that because this is multiplied. So the only way that you can remove this is by dividing both sides by 2x. Okay, so 2x is cancelled. So you're left with y and then over 2x. So negative 1 over 2x. So this is your y equation. All right. And then what's next? You need to substitute this to the other equation that you did not choose. So the first equation is 2x plus 3y plus 2. So you see this y, it will become this one. Okay, so instead of y, it's now negative 1 over 2x. And then solving this, okay, so please listen carefully, you have your fraction. Um, okay, so bring down, and then this down. So you multiply this, you'll get negative 3 over 2x, right? And then simplify this. How do you simplify this? So basically, class, your common denominator is 2x because this is over 1, this is over 1. So 2x. And then how did I get this 4x squared minus 3 plus 4x? So 2x divided by 1 is 2x. So 2x times 2x is a 4x squared. And then, of course, this one, it's just the same. It's still 3. And then how did I get 4x here? So 2x divided by 1 times 2 is 4x equals 0. And then how do I remove the fraction? So you cross multiply this one. So if you multiply 2x and 0, obviously the answer is 0. So therefore you have 4x squared plus 4x minus 3 equals 0. So for this one, class, I did not use factorization because x squared here has a number. It's trickier to factorize this kind of equations. So what I did, I just used the quadratic formula. So this is my A, B, and C. All right, so this is the quadratic formula. So negative B, or negative 4, plus minus square root of 4 squared minus 4AC. So A is 4 also, C is negative 3. And then over 2A, 2 times A. So 2 times 4. Okay, so moving here. Okay, so when you simplify this, you'll get 64. And 64 is a perfect square number, right? Okay, so bring down negative 4. So this is positive and negative 8. So what I did is I separated them now. Plus 8 minus 8 and then over 8. So simplifying this, you'll get 0.5. Simplifying this, you'll get negative 1.5. That's it for your 2x values. If you go back to Desmos, we are correct. So we have your 1.5 here, or negative 1.5, and your 0.5 over here. Okay, so let's now solve for the y values. Now, when x is 0.5, sorry guys, I wrote it like this because I'm out of space. So x is equal to 0.5, right? So therefore y is equal to, by the way, I use this one again for this. Okay, so negative 1 over 2x equals negative 1 over 2 times x is 0.5. So therefore, y is equal to 1. So my first point is 0.5 and negative 1. All right, and how about for my second point? So if x is negative 1.5, y is equal to, so negative 1 over 2 times negative 1.5. So therefore, y is 0.33333. Okay, so yeah, this is my second point, 1.5 and 0.33. Okay, do you guys have any questions with number 13? Okay, so yeah, that's it for number 13. And then I only have one more example for today. I haven't discussed about um, fractions. What if we have fractions in our question? This one. This is on page, I can go back, page 32. Okay, page 32. Okay, so what if we are given fractions? So class, basically it's just the same, but you cannot use fractions to solve these two simultaneous equations. You need to remove the fraction basically. So what I did first is I went ahead with the linear one, and then I made y the subject of the formula. So it became y is equal to 3 plus x. And then the fraction here, to get rid of this, is to, of course, LCD is xy. So xy divided by x, so x gets cancelled. Y times 2 is 2y. And then xy divided by y, so y gets cancelled. So x times x is x squared. And then, of course, bring down 1. And then what do we need to do to remove the fraction? We cross multiply this. So xy times 1. So it becomes xy over here. And then just bring down this one. All right. So after that, this is now, we have removed the fractions. So what do we do now? We can now substitute the value of y to this and to this one. So please observe, class, that you have two values of y, or two y's in your equation. So we need to do it twice. Okay, so 2 times y, it becomes now 2 times 3 plus x, and then this one, bring down. So x times y becomes x times 3 plus x. So we did it twice. Okay, so removing the brackets, you'll get this. Bring down this. Also, removing the brackets, you'll get 3x plus x squared. And then change this to standard form. So x squared, and if you transpose this here, it becomes plus x squared. So that's how I got 2x squared. And then 2x here becomes minus 2x, so it's just plus x. And then, of course, 6 put here becomes minus 6 equals 0. So this is already in standard form. Okay, standard form. Okay, so what's next? So either factorization or quadratic formula. So I use the quadratic formula. Okay, I use the quadratic formula. So this is A, B, and C from here. So this is negative 1 plus minus square root of 1 squared minus 4 times 2 times negative 6 over 4. And then evaluate this, you'll get square root of 49. Okay, what is the square root of 49? It's a perfect square. The square root of 49 is positive and negative 7. Okay, so going here, okay, so we have minus 1 plus 7 over 4 is equal to 1.5, and then the other one is equal to negative 2. So therefore, those are your x values. How about the y? So the y values will come from this equation, and then just substitute the values of x. So when x is 1.5, y is equal to 3 plus x, or 3 plus 1.5. So therefore, y is 4.5. So your first point is at 1.5 and 4.5. Okay, so this is your x and y. And then for your second point, when x is equal to negative 2, what is y? Y is equal to 1. Okay, and then yeah, so that's it. This is your answer basically. Okay, so